Okay, hi everyone. Today I'm going to be working through a beginner data science project, and we're going to be using Pandas and Python for this project. What we'll be doing is analyzing survey data from a Star Wars survey that was done by a website called 538. And this data is actually fairly messy, so we'll be doing a lot of data cleaning, and through that data cleaning we'll be able to create some interesting visualizations. So without further ado, let's get started. So we'll be using a tool called Jupyter Lab. If you're familiar with Jupyter Notebooks, this is a tool that lets you use Jupyter Notebooks, but also do other things like edit Python files, create terminals where you can run command line commands, as well as other functions that you can get through add-ons and other packages. So Jupyter Lab is essentially a more versatile and advanced Jupyter Notebook. So I'll be using Jupyter Lab, and if you want to install it, you can install it through pip just like a normal package, but I'm going to assume you already have Python and Jupyter Lab installed. So let me go ahead and create a new notebook. I'm going to give this notebook a name. So let's rename this to Star Wars, because we'll be analyzing our Star Wars survey data. And the data we're going to be getting is online. So it's actually at a GitHub repository. So we need to download the data, and we'll use the requests package for that. And we'll be using Pandas to analyze our data. So we'll install Pandas and the requests package. And in Jupyter Lab, you can do that through this exclamation mark, which lets you run commands in the terminal from the notebook. So it's really handy. So we'll do pip install pandas and requests. And I'll go ahead and run that. I already have them installed, so this is why we get requirement already satisfied. But if you don't, it will go ahead and install them. I'll go ahead and delete the cell because we don't need it now that we've installed those packages. So to download our data, I mentioned we're going to use the requests library. So we'll import requests. And then what we'll do is we'll use the get method of the requests library to download the data from a specific URL. And I'll just paste the URL in because it's easier that way. But I'll also put the URL in the description of this video so you can get at it if you need it. So that's how we'll actually download the data. What this get method does is it makes a request to the URL and downloads the file, in this case, starwars.csv. And then what we need to do after it downloads is write it to a file. So we'll open a local file called starwars.csv, and we'll open it in write mode using W+, which indicates to Python that we want to write to the file. And we'll call that file f. So then what we can do is just f.write. So basically when a request is made and the request library gets the data, this text property actually has the file contents. So this will write it to the Star Wars CSV file. So let's go ahead and run this. And what we will be able to see is that Star Wars CSV file being saved. It looks like it's saved in a different directory, so we can go ahead and open it up in that directory here. Just took a second to download and save. So we now have that starwars.csv file saved, and we can look at it in Jupyter Lab. So Jupyter Lab has a nice preview interface for CSV files, so we can look at the structure of the data. So we can see the data has different columns. So respondent ID, which is the ID of the person who answered the survey. We have this column, which is, have you seen any of the 6 films in the Star Wars franchise? Yes or no. We have this column, do you consider yourself to be a fan? Again, yes or no. The blanks mean that someone didn't actually respond. So for example, this respondent only answered the first question and didn't answer the second question. So that's why it shows up as blank. And then we have a few other columns. So which of the following Star Wars films have you seen? And this is interesting. The actual survey question must have been a multiple select checkbox where you could check off multiple things. And you can see these next several columns actually indicate if the person saw a specific movie or not. So this column indicates if they saw Star Wars Episode 1. This indicates if they saw Episode 2, Attack of the Clones. This indicates if they saw Revenge of the Sith, and so on. So basically, each column is a yes or no about whether they saw that specific movie. Next, we have some columns that are ranking people's favorite Star Wars films in order. So a 1 means it was their favorite movie, a 2 means it was their second favorite movie, and so on. And then all of these columns that's what they are. And then this indicates just favorability of different characters. So how much do you like different characters in the film? I'm not going to go into all the columns. In this project, we'll actually only be working with these first few columns because there's a lot of data cleaning to do, and cleaning up these columns will actually take us a good amount of time. So we're going to work through cleaning these columns today, the ones that I already talked through and have highlighted. So let's go back to our notebook where we can continue to actually work with the data. So we actually have our data in a CSV file now. So our next step is to actually import Pandas. And I like to import it as PD just because instead of typing out Pandas every time you call the library, you can just type PD. It makes it a little bit easier. And then what we can do is we can read our data into a data frame. In this case, it's called starwars.csv. There is one interesting thing about this specific CSV file. Normally, CSV files are encoded in an encoding called UTF-8. An encoding just indicates how different sequences of bytes map to actual characters. Don't need to worry about it right now. But this is actually encoded in a different encoding. So we'll pass in this encoding parameter to specify that. In most cases, you won't need to specify this. This is just a unique file that is in a different encoding. So don't worry too much about this, and we'll just read the file in and continue to work with it like normal. All right, so now we've loaded the data frame in. Let's take a look at the first few rows. So we'll use that head method on a data frame to look at the first few rows of the data. And the nice thing about Jupyter Notebook and Jupyter Lab is that it gives you a really nice preview of the first few rows. So we can actually see what the data looks like in Jupyter Notebook. So what we can see here is the first row just looks like a subheading row. We saw that in the CSV file as well. So we need to figure out how to remove this first row. We can also see that the data is really messy. So here our responses for the first column are yes, no, and we probably have missing values also. In the second column, we have missing values, yes, no. So we're gonna need to do a lot of data cleaning to actually start analyzing this data. So the first thing we'll do is we'll cut off this first row. As I mentioned, we're not gonna need it. So let's go ahead and do that. So what we can do is we can just do this. So what this is saying is assign back to the data frame from the first row onwards. So what this iloc does is it says integer location. So irrespective of the index, it'll go from the first row and select the whole rest of the data frame. So essentially what we're doing is we're just cutting off this first row. There's two ways to index in Python. You can use LOC and ILOC. LOC uses the index, which is these bold numbers on the left. ILOC just uses the integer position of the row. So in this case, the index and the integer position are the same, but I like to be explicit and use ILOC instead of defaulting to the index. Because sometimes you can have unexpected behavior where you might slice some rows out of the data frame and suddenly the index doesn't actually match the integer position of the rows. So let's go ahead and do this, and then what we can do is take another look at the data frame to see what happened. And we can see here that first row is missing. This row had index 0. It was row number 0 because in Pandas we start our row indexing at 0, and now it's removed. So our first row is now starting from 1. And this is where the difference between the index and the integer position comes into play. So this row now has index 1, but it has integer position 0. So I'll show you what I mean by that. So if you do that, you'll get the first row in the data. But because the index is 1, the integer position is still 0. The integer position will always stay the same. So you get the same row with ILOC 0 and LOC 1. So in this example, in this project walkthrough, I'm gonna use ILOC just because it makes it easier to select the right row. So whenever you do ILOC 0, you always know you're gonna get the first row of the data frame. So I will continue to do that. Now we've taken a look at the data, and we can take a look at the columns as well. So these are all the columns in the data. You can see, similarly to when we looked at the CSV file, you can see the same columns. So we're going to clean these columns starting at the very beginning. So we're going to start with these two columns. Have you seen any of the 6 films, and do you consider yourself to be a fan? So we're going to clean these two columns first. And in order to do that, we'll create a new data frame called cleaned data frame, and we will only select the columns that we want to clean. I like to do this just to keep the data that has not been processed yet separate from the data that has. Just makes it simpler to tell which columns are clean and which ones aren't. Okay, so we're going to select these 3 columns. So respondent ID, have you seen any of the first 6 films, and do you consider yourself to be a fan? So this new data frame called cleaned DF will only have those 3 columns. So let's take a look and make sure that happened correctly. So you can see it just has 3 columns. This is going to make it a little bit easier to work with and easier for us to clean the data. So the first thing we want to do is these are yes, no. It's relatively hard to work with yes, no because it's string data. And what it's hard to do in Pandas is just segment based on that and be able to actually select and create subsets based on that. It's a lot easier if we convert these to Boolean columns, which are true, false, because that's a format that Pandas can understand, and then we can use it to more easily index our rows. So let's go ahead and convert these to Boolean columns. So the way we'll do that is Pandas has a method that basically enables you to map new names to columns. So what we can do is we can set up a dictionary saying what the old column name is and what we want or the old value is and what we want the new value to be. So if it's a yes, so if the person answered yes here, we want that to map to true. And if the answer is no, we want that to map to false. So we'll set up a dictionary, and then what we can do is we can actually run a command called map to actually map our new values. So what we'll do is we can map like this. So you see this one column. Have you seen any of the 6 films in the Star Wars franchise? We'll select that column, and then we'll use this map command to actually map all the old values to new values. So let me run this command. Right, okay, so this error came up because I didn't copy the data frame when I did this. So what I can do is type copy here. Now clean DF is a copy of the original data. It's still the same data, but it's a copy instead of just referencing the original data in memory. It's a little bit complicated, so I'm not going to get really deep into that. But generally, if you see this error, try making a copy of the original data instead of just assigning values to what you subsetted. So I'll go ahead and run this again. You see our error is gone because now clean DF is a copy of the original data instead of just a reference to the original data. All right, so let's take a look at this and see what we get. You can see this column is now true false instead of yes no, which is exactly what we want. So we can go ahead and do that with the other column too, which is, do you consider yourself to be a fan of the Star Wars film franchise? Which is just the same command again, but replacing the column name with the other column name. So this will be the .map command again. And let's take a look again to see what we have. So you can see this is now true false. There's still an NaN, which just indicates that the person didn't respond. We want to preserve that because it's actually different from false. False means the person answered, I'm not a fan. But NaN means the person didn't answer. So it's actually very different, and we don't want to just overwrite the NaNs with false. So now we've converted both of these columns to Boolean, which makes them a little bit easier to work with. And now what we can do is we can actually take a look at the value counts for each of these columns to see, hey, how many people said that they saw all 6 films? How many people considered themselves to be a fan? So the way we do that is we use the value counts command. These column names are a little bit annoying to work with. We'll fix this shortly. For now, I'm just going to copy paste them because they're long. So Pandas has this value counts method, which tells you, hey, in this entire column, how many were true and how many were false. So we can see in have you seen any of the 6 films, 936 people answered that they had, and 250 people answered that they hadn't. We can do the same thing for the second column, which I'm just going to copy, paste, and replace the column name to make it easier. There we have it. So we can see in the second one, do you consider yourself to be a fan? 552 people said yes, 284 people said no. You can see just intuitively, these 2 numbers add up to less than these 2 numbers. That's because quite a few people didn't answer the second question, those NaN values. So just keep that in mind. All right, so now we have some early data cleaning and some early interesting results that we found by analyzing the first 2 columns. Let's go ahead and analyze the next few columns now. So the columns we're going to analyze now are these. Which of the following Star Wars films have you seen? And this data is a little bit messy and awkward to analyze, so we're going to have to do a good amount of cleaning. As you can see, it's 6 different columns, and each column indicates if the person saw a specific Star Wars movie or not. So this column indicates if they saw episode 1, this indicates if they saw episode 2, and so on. So if it's blank, it means they didn't see it. If it's not blank, it means they saw it. So that's how we'll work with these columns. All right, so what we need to do is actually convert these to true-false columns as well. And the way we'll do that is to, again, pull some of these columns over into our cleaned data frame. So the way we do that is we use the merge command. And what we're saying is, hey, we're merging our clean data frame, which right now has these 3 columns, with some of the columns from the original data frame. So specifically, we want columns 3 through 9. We'll again just make a copy. I'm pretty sure the merge command automatically makes a copy and we don't need this, but I'll just leave it in to be 100% sure we have a copy and we don't get the error down the line. But you can experiment with both and see what works. So what this command is doing is it's saying merge our clean data frame with columns 3 to 9 from the original data. And those are these columns that we looked at earlier. These columns that say which of the following Star Wars films have you seen? And it's saying use the index to actually merge. And the index is this bold number on the left, and it's the same in both data frames. So we can use that index to basically tell Pandas how to combine these data frames. So let's go ahead and do that merge. That is because I typed iLook twice. So, and then we can take a look at the clean data frame. So now we see we had our original 3 columns and we added these other 6. So now our job is to clean up these 6 columns so we can analyze those as well. When they're coded like this, it's very hard to actually analyze. So we're going to convert them to true-false. So what we can do is we can actually use the Pandas not null function to convert these to true-false. So whenever there is a value in this column or this column, we want it to say true, right? So if the person watched Star Wars Episode 1, then we want this to be true. If it's missing, which means that they didn't select this, then we want it to be false. And there is a little bit of problem with the survey design because NaN can also indicate that they didn't actually answer the question, but we have no way to actually differentiate between them not answering the question or them not selecting anything. So unfortunately, we're gonna have to assume that meant they didn't watch it if they didn't select it. So that's what we'll do. So the way we do this is we say, so we take columns 3 through 9, again, and we use this not null function. So actually, before we assign, let's take a look at this. So you can see if if there was a value here, so this is this column, if there's a value here, it's true, but if it was NaN, it's false. So this basically enables us to convert these columns to Boolean really, really easily. So let's just assign this back to the clean data frame. And we can look at the clean data frame again. See? So now what we have is true false. So instead of having to deal with these strings, which indicate someone watched the movie, now we just have a true false that's a lot easier to work with. So what we can do now is make the columns easier to work with. So I'm sure you're tired of watching me type out these really long column names. So we'll actually rename the columns to make it simpler. So our columns are going to be ID for the first column, which is respondent ID. I made a mistake here. Okay, so the mistake I made is I assigned this to the entire data frame. What I instead should have done is only assigned it to these specific columns in the data frame. You can see this data frame is now missing the first 3 columns. So in order to fix this, let me just rerun some of our earlier things. So what I'll do is I'll run this. This will recreate our original clean data frame with the first 3 columns. I'll rerun this, which does the cleaning. I'll rerun this too, which does the other cleaning. And then I'll rerun this merge. All right, so now I can fix this command. So it only assigns this to columns 3 and up. And now when we run head, yes, we can see we actually have all of our columns. So the nice thing about Jupyter Notebook is you can go back and actually rerun older cells if you made a mistake. So it's easy to recover from mistakes like you just saw. So our clean data frame now has all of our columns, and all of our columns are clean. But what we're going to do now is go ahead and rename the columns to make them easier to work with. So our first column, respondent ID, we'll rename to ID. Our second column we'll rename to scene any. Our third column we'll rename to fan. Our fourth column we'll rename to scene 1. And then we'll do scene 2, and so on. And that'll just indicate if they saw movies, the first movie, the second movie, the third movie in Star Wars. All right, so those are our column names. And now what we can do is actually overwrite our original column names with these cleaned up column names. And now when we look at the first few rows, we see, yes, way nicer, much easier to work with columns. We don't have to type out those super long names anymore, and it's just simpler to display. Okay. So what we can do now that we've cleaned these up is just count how many times people saw each movie. So we can figure out what the most seen movies were. And the way we can do that is we have to cut out this first column because it's not a true-false column. It's different from the other columns. So what we'll do is we'll say from column 1 onwards. So this is saying take all of the rows, but only take columns from column 1, which is scene any, onwards. So we basically ignore the ID column. And then we're going to use apply. So what apply does is it runs a function on every column in the data. So we're going to run this. We used value counts before. We're just going to run this on every column at once. It just makes it's simpler than typing out. Earlier we used value counts on 2 columns. It's just easier than typing it out individually for each column. So you can see this gives us how many trues and falses we had for each column. So for scene any, we can see this matches what we did earlier, same for fan. But for scene movie 1, scene movie 2, scene movie 3, we can see how many trues and falses we had. Now, the real fun is when we can convert this to percentages. So what we can do is we can assign this to counts. And then what we need to do is find how many total items are in each row. So what we can do is we can find total. Again, just take everything from the first column onwards, and we'll use apply again to apply a function across each row. And this time, our function will just be a function to count how many items are in each row. Okay, so let me explain. So normally apply, so what this apply does is it iterates across each column. And then for each column, it passes that into pandas.valueCounts. So that works well when you have a function you want to pass into apply and you want to apply a function across each row. But in this case, we want to apply a method, and that's a method on each series. So each column in Pandas is actually a series, and we want to use a method. So a lambda function enables us to use a method in a simpler way. So in this case, we're applying a lambda function, which is running a method on each series. So we'll just take a look at total to just see what it is. It's just how many rows are in each column. It's taking out the NaN responses. So you can see fan has fewer rows. And then what we can do is we can divide counts by total to get our percentages. So we can see the percentage of people that answered true, the percentage of people that answered false for each one. So it looks like the highest percentage of trues was on movie 5. So the most people in this survey have seen the 5th movie, Star Wars Episode 5. All right, and yeah, we can check what the name of Episode 5 is, because I do not know off the top of my head. The Empire Strikes Back. So most people have seen Empire Strikes Back. Second most is the 6th, which is Return of the Jedi. I should have known that. Yeah, okay, all right. We'll pretend I knew that. Okay, let's keep going now. And now that we have our counts divided by our total, we can actually make a nice plot. So let's assign this to percentages. And let's actually plot percentages. And Pandas has a really nice bar plot method where you can just call it and create a bar plot. I already have matplotlib installed, but if you don't, you would need to type pip install matplotlib at this point to install matplotlib to actually make this plot. But yeah, you can see here the percentages for each column and how many, the percentage that responded false, percentage that responded true. We actually don't care about the first 2 columns here because they're different from the other columns. We want to really figure out who saw each movie. So we'll actually go ahead and cut out the first 2 columns. When we make this plot, I need to use iLook. All right, so this shows you the percentage who answered false and true for did I see each movie. So again, you can see that episode 5 and episode 6 got the most people saying they saw them, along with episode 1, which I think is the Phantom Menace. Yes, it is. Great. Okay, so we've made that bar plot. Now let's take a look at the next set of columns that we want to clean up, and that's this set of columns. So please rank the Star Wars films in order of preference. So 1 is the favorite film, and 6 is the least favorite film, as you can see there. We have several columns that indicate that. And there's a couple of issues that we need to clean up here. One is we need to add the right column names. The other issue is that these columns are not in the right data type. They're not floats. So these actually aren't coded as numbers. They're coded as strings. So what we want to do is convert them to numbers to make them easier to work with. With numbers, we can find the average, we can find the sum, we can do all kinds of things that we just can't do with strings. So we'll go ahead and convert these. All right, so let's do that. So the first thing we'll do here is we will again merge in the columns that we want from the old data frame into the new data frame. So our clean data frame is our new data frame. And our merge will take columns 9 through 15. So what we'll do, so we're taking columns 9 through 15 from the original data, and we are again copying. I'm not sure if you need this, but you know, just be double safe. And we'll go ahead and merge here. So we can take a look at this to see what's going on. And we see to our original set of clean columns, we've now added these extra 6 columns that we will now figure out how to clean. So what we can do is we can check the actual data type. I mentioned that they're not stored as floats, but don't take my word for it. Let's go ahead and look at it. Clean df. All right. So data type O, this is the object data type in Pandas. It's when it can't necessarily assign it to any particular data type. And the thing that we'd really like to do is take the average of each column, right? So if we take the average of one of these columns, it tells us on average how highly did someone rate this movie. So if we tried to do that here, we wouldn't be able to do it. And the reason why is it's treating these as strings. So we need it to convert it to integers or floats, which are the integer type that we want, before we go ahead and do further analysis. So what we can do is go ahead and select columns 9 through 15 from this clean data frame. And then we will convert those columns to float. So here, let's take these. And then we use the as type method to actually go ahead and convert them. So as type will convert from one type to another. And let's take a look, let's run this command again so we can take a look at the data type now. We can see it's a float 64. And what we can do now is we can do something like take the mean, because now it's a numerical object, and Pandas knows how to take the mean of numerical items, but it doesn't know how to take the mean of a string, because there is no such thing as a mean of a string. So we've now converted it, and we can proceed. Okay, so we did that conversion. Our next step is to rename these columns. So what we'll do is we'll go ahead and add, so we made a list called columns before. We'll go ahead and add in some more names to this, just to rename these columns. So this one we'll rename to ranking 1. This is how highly someone would rank the first film. Then we'll make ranking 2, ranking 3, ranking 4, ranking 5, and ranking 6. So those are going to be our ranking columns. And then we'll just assign that to the column names. So this will overwrite the column names with our list of columns. And we can take another look and see what's going on. And we can see all our columns are now renamed, which is awesome. And this will let us do exactly what we want. So our next step here is to find the mean of each column and to graph that mean as well. So I showed you how to take the mean of a single column, but we want to take the mean of multiple columns. And the way we do that is I'm just going to copy and paste this. We just index more columns. So we've indexed from columns 9 to 15, and this is the mean of each of those columns. Now what we can do is we can actually plot that. Pandas is great. It lets you plot almost anything. So we can go ahead and make a bar plot, and we can see where people rank things. Remember, lower rankings are better. If someone ranks something a 1, it means they liked it the most. If someone ranks something a 6, it means they liked it the least. So it looks like people like episode 5 the most, then episode 6, then episode 4, which is not surprising. Those were the original movies, and those tend to get a lot more critical acclaim than the newer 3. Remember, this survey was taken a few years ago before some of the even newer movies came out, so those are not included in this data set. All right, so we've done a good amount of work here. What we've done is we've taken these columns, so the first 3 columns we cleaned up and analyzed to figure out how people responded. Then we cleaned up these next 6 columns to really figure out which movies people had seen and which ones they hadn't. Then we took the next 6 columns and did some more data cleaning. There's a lot more columns in this survey. So there are these columns about which characters people view favorably or unfavorably. Also needs a lot of cleaning. There's other columns about which character shot first. Are you familiar with the expanded universe? Do you consider yourself to be a fan? There's also demographic questions. So these are quite interesting. So gender, age, income, education. You can actually use these demographic factors to segment the original data and see, okay, did people's preferences change based on these demographic factors? If someone was younger, do they like the newer movies better or the older movies better? If their education is different, do they have different preferences? So that's actually a really interesting next step, is to take a look at these demographic factors and see if you can actually segment and do some of this analysis using those demographic factors. For instance, what you could do is you could look at this data only for cases where the gender is male. Right? So you could do that. And then you could figure out, okay, does this change any of the patterns that I saw already in the data? We've gone through some of these patterns, which movies people had seen, which ones were their favorite. Does it change anything if someone responded that they're male? So that could be a really interesting next step. There's plenty of other next steps you can take with these questions as well. These need cleaning similar to the cleaning we've already done. So that's something you could do to figure out which characters are viewed the most favorably or least favorably. So I hope you enjoyed this project, and that's it for the guided walkthrough. But remember, there's lots of steps you can continue to take to build this project out on your own. Thank you so much.